Here we go, guys. We're going to look at some of the things that we already started in this chapter with tangents. And in class tomorrow, we want to look at these things on the sketch pad to help you move along with them, okay? This vocabulary you got to know, okay? And it's all pretty much summarized here. Tangent is a line touching a circle of one and only one point, okay? That point is called the point of tangency. And we also realize that, and we show you this on Sketchpad, that the tangent will always meet the radius at right angles. The tangent will always meet the radius at right angles. Key concept, very key concept, okay? The theorem 1-1, if a line is tangent to the circle, then it is perpendicular to the radius drawn to the point of tangency. That's going to be there's going to be another theorem which will say the converse of that. We'll come to that in a moment, okay? We're going to look and see how we can solve these problems, okay? They're going to be solved by Pythagoras, and we're going to look at that with the sketch pad as an example tomorrow, okay, to illustrate how that's done. Here's theorem 11.2, which again is that converse statement of 11.1, stating that, you know, if a line is perpendicular to the radius, then it is tangent to the circle. So we're going to get a lot of mileage out of that. Okay, here we got a tangent, we've got a right angle. Right angle says Pythagoras will work for us, and we'll look at those examples again. Okay, let's see what else. Okay, objective 2. Objective 2 talks about inscribed and circumscribed. Inscribed and circumscribed, okay? We know that inscribed sits within, but when it sits within, okay, if the circle here is inscribed in the triangle, then the sides of the triangle are tangent to the circle. Tangent to the circle. We could also say that the triangle is circumscribed about the circle. All right, and we'll ask you to remember how we generated those things. We'll do them tomorrow in Sketchpad. Theorem 11.3, we're going to demonstrate this. I want you to think about how you're going to demonstrate this and prove it with Sketchpad tomorrow, okay? Don't forget what it says. Two segments tangent to a circle from a point outside the circle are congruent, okay? Two tangents, okay? In other words, these two segments are tangent to two different points, okay? And they meet at some point out here, okay? And their lengths are going to be equal. We're going to ask you to prove that via Sketchpad tomorrow, okay? We're going to look at what happens when this triangle is circumscribed about a circle, or the circle's inscribed in the triangle. We're going to see how the parts are split off, okay, using this theorem 11.3. Things to think about for what we do in class tomorrow. We'll have some of these exercises to look at, implementing those ideas. So those are going to come, we're going to be able to work with those and illustrate those with Sketchpad. So look those over, those exercises in 11.1, because you will have them in class tomorrow, along with some Sketchpad assignments that will help illustrate these things, okay? So there's a little preview of upcoming things for tomorrow, okay? Simple enough. Remember that, refresh that 11.1 stuff, the vocabulary. Go back over, because in one of the previous Sketchpad assignment, we illustrated this whole big idea here. This is the big idea. This is the big idea for this section, that a tangent and a radius always meet at right angles. Always, 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 okay? Key concept, carrying it through the rest of this chapter and onward into some other very important ideas in your future math classes. Okay, there you have it. Know those theorems and think about how we're going to present them on Sketchpad tomorrow. Okay.